Okay. Okay, what do you know about clustering? For the previous lecture, we cover classification, right? So for classification, you need to have labels for your model to learn about the pattern, about the rules that they need to satisfy to be classified into certain classes. So when we compare with clustering, clustering, they do not have any label to begin with. So what you have is just rows of data. So your task is to cluster them or group them based on their characteristic, based on similarity of their features. Okay? So clustering is used whenever you do not have any labels, or you want to group your data into few groups that share similar characteristics. So if you look at the map here, so we have covered this, right? We have covered linear regression. We also have covered classification, and specifically we look into the decision tree, right? So based on the map, okay, today we'll cover this, and next we will cover the association rules, which is um, this one here. Okay, so by the end of the course, since this is called fundamental of data science, so basically you have covered this one. Okay, so in the next course, you will be learning ensemble, deep learning, and more some of the models that we didn't cover today in this course. Okay, so that's the jalan cerita dia. Okay, so for today, what we will be covering will be how do we define the clustering based on the similarity, and how do we measure the quality of the clustering that we have. So today we will learn how step by step how do we perform the clustering grouping, and then what are the issue yang we need to look into when we perform clustering. Contohnya in business, you want to segment your customer kan? So satu high value purchase because they have high salary, and yang satu lagi medium and low purchasing power. So you need to segment your customer so that you can promote your product based on targeted customer. So that is segmentation. You also need to be able to differentiate between unsupervised and supervised. So supervised means you have labels, because we use the label as a guideline, supervised. But in clustering, they call it unsupervised. There is no label. So we just group them based on the features ataupun ciri-ciri yang sama itulah. Okay, if they do not have similar characteristic, they will be placed into different cluster. And the main issue yang we need to look into is berapa cluster yang kita ada, and what is the best number of cluster. How do we measure? How do we measure the quality of the cluster? 3 cluster, 4 cluster, 10 cluster. So that is our task, because we need to answer to our boss. We say, okay, for this data, the best cluster would be 3, and you need to justify. Okay. For most people, they just say, okay, I can do clustering 10, but they cannot justify. Of course, you get the result, but can you get a much better clustering result? To be able to do that, you need to be able to access the result. Okay. So, like I mentioned just now, if all the members belong to one cluster, that means they will share similar characteristic. If they belong to different cluster, meaning that they have different character, the distance is much more, menunjukkan ciri-ciri dia itu berlainan lah. So the application of this clustering, like I mentioned just now, segmentation of customer into groups with similar demographic or buying pattern. So easier for you to save money. You know this guy will buy this product only, so you will promote this product to a specific cluster only. Or because clustering is a grouping, but sometimes you have this one guy which is not belong to any one of the cluster. So this is what we call outlier. Okay, outlier is one item or one data that is not belong to your cluster. So this is what we call abnormal. So this can be used to detect, for instance, network intrusion because tiba-tiba network congestion night, or someone trying to break your password. So we can use this one, outlier. And the last one is simplifying extremely large data set. For instance, if like for last time I mentioned about discretization, right? If you have 100 marks, you will have contohnya nomor bulat 1 sehingga 100 lah. Tapi if you put them in grade, you will have A, B, C, D. So from 100 different values to 5 only. So you are simplifying, right? Similar to this, if you have 100 features, but you use the cluster ID to simplify this 100 features, saying that I only have 5 cluster. So from 100 features atau 100 column tu, you use one features which is the column ID to simplify the representation of your data. So you simplify the data. So instead of saying that you have 100 features atau ciri-ciri yang menggambarkan raw data tu, I use the column ID because the column ID group the data into 5 cluster, and setiap cluster tu we can describe the cluster. So inilah contoh-contoh how we can use clustering which is powerful, and depending on the situation of your data itulah, if you do not have label, go for this. If you have labels, you go for prediction, okay, or classification. Okay, any question? No. Okay, so like I mentioned just now, clustering will tell you which group of example are closely related. So what we want to show here is that there'll be a grouping in your data set. So your task is to identify this grouping. For instance, like this, we want to find groups of objects such that object in the same group will share similar characteristic. Okay, and object with different uh, cluster will have different characteristic. Okay, so our task is to make sure that the cluster, the intra cluster distance are minimized, very compact. And the inter-cluster, which is the distance between cluster, will be separated far away. Yeah? So that is our task. If we could compare with this, so mana satu yang bagus? The left one lah, because they are very compact and they are far away separated. But the nature of the data is we cannot guarantee your data looks like that, kan? Your data might be on the right side. So the issue yang we need to think about is how can we ensure that we have the right K, which is the right number of cluster to represent our data. Okay? For instance, if I give you this, how many cluster do you think? 3, 6, 2, 1. Huh? So to determine the best number of cluster, we need to be able to assess. We need to be able to evaluate what is the best number of cluster. So we could have 2, but please justify. We could have 6. How can you justify? Or we can have 4. How can you justify? This is based on our observation, right? But this, okay, this is 2D. 2D means you have 2 features. If you have 3 features, 3D lah. 4 features, cannot imagine, right? So 100 features. So by saying that we need some formula to measure or to quantify the quality of the cluster that we have. But at this moment, you kena belajar dulu, how do we perform the cluster? What are the steps required to start the clustering and then finally stop and say, this is my cluster. Contohnya, if you say K equal to 3, so how do you start? And how do you end? When do you stop? Okay. Before we go further, in the next class, machine learning for the data science, we will cover the remaining of the cluster because clustering they have more advanced model. But for this one, we say K-means is the foundation. From there, we can move to more advanced model. So for clustering, we have actually 3 types, but this one they say partitional and hierarchical clustering. So partitional, where you do not have overlapping. Okay, so you look from the top and you see down and you see cluster. There is no overlapping. Okay, so this is K means clustering. K refer to number of cluster, means refer to you taking the average of all the member to compute the center. Okay, this is hierarchical clustering, in which when you see from the top, you will see overlapping cluster. So what happened here is that you treat individual item tu sebagai cluster. So for each of the member yang nearest to each other, you will start combining, and then you take the center here combined with this one and so on. So you are building the dendrogram or hierarchical format of the clustering. So from the top, you will see you can cut across here to have 2 cluster, or you go below to have 3 cluster, and so on. Okay, so for this one, there is no issue of what is the best clustering, because you can always cut across. Yeah? But for the overlapping, there'll be some issue. We will go over that one. So that is the differences between partitional and also the hierarchical clustering. You will study this in the next course, but today you will cover k-means clustering only, which is the partitional. This is the most basic model that they use for clustering. Okay. So what are the steps involved? The first thing that you need to do is you need to set what is the value of k. K is the number of cluster. Okay. Okay, you pick what is k. Huh? 2, 2. What is nomor 2? No, k. K is number of cluster. Contohnya lah, we want to simulate this, k. Okay, dalam kelas ni, how many cluster do you think? How you know 4? Some people say 2 or 3. Okay, so let's suppose we take 3 lah. We take 3 cluster, k equal to 3. Okay, di mana kita mula? We cannot say, because in your data set, you cannot see what inside your data set, right? So what we'll do is, okay, we set k equal to 3. Now, I will pick randomly 3 orang dari kelas ni. Okay, so I will pick 3 data point. Contohnya, if we have 100 data tu, okay, contohnya dalam kelasnya ada 103 orang, I will pick 3 person randomly. Okay, randomly saja nih. Contohnya I pick yang very obvious lah supaya senang lah. Kita punya handsome guy baju merah biru. Siapa nama? Azail. Okay, so you are the first point, randomly pick. And yang seorang lagi yang the lady in red. Siapa nama? You lah. Yes. Yo. Okay, so you are the second randomly selected person. And seorang lagi, yang depan ni lah. Siapa nama? Kiss. Oh, okay. So Kiss, Yong, and Azai. So coba berdiri supaya people know you. Okay, you are the three center. You are the three center, right? So we have all your friend here. Okay, for instance, yang duduk 3 orang di belakang sana tuh, you need to pick your nearest center. Mana? Azael or Kiss? Okay, you pick sana lah. You? Kiss lah. Okay. Yang baju purple nih. You're nearer to Azael or Kiss? Okay. Yang sini? Definitely Kiss kan? So what happen is that the remaining member nih, dia akan point to the center nearest to them. Okay. So contohnya, siapa nama baju purple? Brinjal? Pritchard. Okay. So you are nearer to Azael. Okay. So You di sana lah, Mr. T, okay. Ian, okay. Yang di belakang si Ian siapa nama? You lah. Ah, you, you dekat dengan Azail kan? Okay, so now if you think that you nearer to kiss, sila berdiri. Nearer to kiss. Nearer to kiss. Nearer to kiss. Okay, so this is the cluster of kiss. Kan? This is the the cluster belong to kiss. So is kiss is the center now. Hah? Macam kiss sudah di tepi sini kan? So kebanyakan member sini. So maybe the next center would be their punya friend sudah. Kan? Okay. So you punya friend siapa nama? Nel, Del. You take over dia punya government. Because you become the center now. Because most of this, the center is macam you. Sepatutnya sini lah, tapi dia ada orang sana kan. So you yang jadi bos sekarang lah. Oke, sit down yang member untuk KISS. Oke, yang nearest to design. Sila berdiri. Mana boleh you berdiri sebab you dekat Yong. You dekat Yong kan? You decide lah, Yong kah? Yong lagi dekat kan? Kan? Okay, so this is the cluster for Israel lah, because kamu dekat kepada dia lah. So Israel sekarang bukan lagi center. Who is the center now? Yang di belakang kayak yang pakai purple, light purple kayak pakai tudung tuh. Iyalah, macam lah. So so you see when you form the cluster, walaupun Israel is the initial center, it will move to the center of the actual cluster yang sudah pernah form. Okay? Okay, now. Yang, where's your member? See? See? Yang berdiri. Yang tadi itu, yang duduk tuh dia yang berdiri. Okay? So now, is Yong is the still the center or ada orang yang will become the center next? Nanti kamu kira distance kamu lah. Okay? Okay, sit down. Thank you. Okay? So what we have done just now is to illustrate this select K point. So we select K, which is 3% randomly. Then for the remaining of the data, we will assign to the nearest center. Okay, we form K cluster by assigning all points to the closest centroid. So what we did is we form a cluster by assigning the remaining of U to the nearest centroid. Then after that, net take over. So that is, we recompute the new center based on the new cluster that we have. Okay. So we will repeat the process until there is no changes of centroid. Dia stabil sudah lah. Tapi if you look at carefully, the the basic step yang kita have biggest influence is we pick Kiss, Israel, and Young. What if we pick Ian and someone from here and someone from the back? You will have different result, right? So that means every time you run a clustering, you need to perform few times. You select K many times. You repeat the process until you get the best one. Okay. Okay. For instance, like this. This is the actual point. This is the optimal, and this is suboptimal. Okay. So our target is to get the original point. We may get this, which is optimal. We may get the suboptimal. Okay, how do we get to this point? So basically, we start with this. Remember that we pick the center randomly. Okay, so let's suppose we pick these 3 points. So like what we did just now, we assign the remaining member to the closest centroid. So for the blue one, this guy no longer a center. So I need to move around here, right? So similar to the green one, similar to the red one, right? Okay, so if we simulate this, they will go to the final centroid, which means that it will stop when there are no changes of centroid. So they can automatically go to the center of the cluster. Okay, so we start with this, and so on. So this is a good illustration, but let me show you this one. Okay, this one we pick one di atas, satu tengah, satu di bawah. So if we run satu kali saja with this, because the centroid is selected randomly, so this one will give you this result, which is not optimal, right? So what happened here? So walaupun you ada 3 cluster, tapi this one you will have problem because the compactness is not there. Okay, compared to the first one tadi. Okay, compared to this. So this one, we have 3 cluster. So just nicely describing your data. Okay, so again, if we go back to the process, how do we find the center? How do we find the center? Okay, if you think this graph, they should have X and Y, right? X and Y value. So if we take the average of X and Y, that is the center for the cluster itself, right? So you take all the member here and you take the average of X and Y, that one will be your center. Similar to this, and so on. And satu lagi yang you need to figure out is when we pick the first 3 center, how do we decide this is closer to this? we need to find the distance, right? Okay. So meaning that if this is contohnya is we have x and y, and di sini pun kita ada a and b. So how do we find the distance between these 2 points? Okay, so we will look into that. The formula that we can use is what we call Euclidean distance ataupun cosine distance. So Euclidean distance is defined as the differences between one vector to the other vector. We treat them as a vector. Okay, so let me show you one example here. For instance, dalam ni we have a few document lah. So a few document, we have document 1 sampai 7, and we have term 1, term 2. This is the content of the document. So keyword 1, 2, 3, 4. And the number here indicate how many times they appear in that document. Okay, so we have 7 document here, 7 document. And we also have the content of the document. The content of the document is this: term 1, term 2, term 3, term 4. Contohnya, this is science, this is technology, this is mathematics, this is quantum. Contohnya lah. Okay? But the number that we have here is the number of time that exists in the document. Contohnya, term 4 ni, they exist sebanyak 3 kali dalam document 7. Okay? So just imagine you have 7 document and you want to group them based on the content. Based on the content of the document. So if we have this number, then we can measure. Okay? So having that background, this is our data set. So contohnya we want to form 2 cluster here, 2 cluster. So we pick randomly. So dalam this example, we have this is your center 1 and center 2. Okay, like the process yang tadi itu, for each of the member, I want to know the distance between that member to both of these. I need to decide dia pergi center 1 K1 ataupun center K2. So how do we measure? Okay, so the equivalent distance that we have basically take the square differences of this and this and sum up the differences, and you simplify by taking the square. Okay, so we'll take that. So meaning that, okay, 3 minus 1, 4 minus 2, 5 minus 5, 1 minus 3. So 3 minus 1, you take the square because you want to nullify the negative portion there. This is 4 minus 2, 5 minus 5, 1 minus. Contohnya macam ni ya. This is 1 minus 3, you get minus 2. So to get rid of the negative symbol too, we take the square. So by taking the square, we eliminate the negative sign. So we add up all these differences. Okay, by adding up the differences, we know what is the distance, and we take the square root to simplify again. So based on this, document 1 and document 3, the distance is 3.64. Boleh. Okay, so the distance between document 1 and document 3 is 3.64. Now we want to find What's that sound? Tak limat dia bilang. Okay. Okay, now, okay, what is the distance between document 1 and document 6? So we take again, okay, the differences between these 3 and 6, which is 3 minus 6. And you take the square. And then 4 minus 8, take the square. And 5 minus 5, take the square. And then 1 minus 2. Take the square, you add up the value, and take the square root, you get the 5.10. Okay, so by using the equivalent distance, we can quantify the distance between document 1 to document 3 and also document 1 to document 6. So can we say document 1 is nearer to document 3? Because they are shorter, right? So we are saying that, okay, since document 3 ni, they are selected randomly as the center of cluster 1. So now document 1 will belong to the same cluster as document 3. Okay. So what is next? You repeat again for document 2. Huh? So now you want to decide whether document 2 ni belong to K1 or K2. So you buat lagi lah. You find the differences, take the square, add up the value, take the square root, you get 1.73. And then you do again for document 2 and document 6. Then you get 8.06. And we know that document 2 is nearer to document 3, so we put them in the same cluster. Okay? What is next? Which one we compare? What about document 3? Document 3, we also need to compare. Tapi since diri dia sendiri dalam tu, tidak payah lah. Okay? So next will be document 4, 5. So document 4 ni, okay, nearer to document 6 because the value is lower here. So we put document 4 with document 6 and document 5 with document 3 and document 7 with document 3. So finally we have this. Okay. So what is next? Bila kita sudah form yang cluster tadi itu, we need to find the new center, right? So the new center is just taking the average. So contohnya for a new center K1, so we take the average of these values, divide by 5. Then you get this one. So similar to cluster 2, we just take average of these two. So 6 and then 8.5 and then 4.5 and 2. So this new center K1 and new center K2, we use this to proceed with the next round, second round. So you will stop this process until no changes of center. But you will not be doing this. The algorithm will do it for you. But make sure you have coded the algorithm correctly. But nowadays, everything is in the library. You just call the function. You just mention k equal to 1. But every time you run the clustering, it will give you different result. Okay. So we start all over again. Then we will stop when there is no changes of the center. Okay, boleh. So what have you learned? The most important part is two things: finding the center and computing the distance between two items in the dataset, which is using the Euclidean distance. Okay, boleh kan? Okay, if I go back to this here, when we want to find a good cluster here, we are looking into what? We are looking into the compactness of the cluster and also how far they are separated from each other. Okay, so now we will look into this. How do we measure the compactness of the cluster that we have? Okay, so before we proceed, how do we find the center? No, how do you find the center of the cluster that already formed? You take the average, kan? Okay. So contohnya, if you have this data set, you have this data that you have, then if you take the average, your average should be here, right? So now you want to find the compactness of the cluster. So the compactness refer to the distance from all your member to, okay, all the member to the center, right? Okay. So this is how we find how compact they are. We want to find the accumulation of distance from all member to the center of your cluster. Okay, so we will use this formula, sum of square. They call it sum of square just to know how compact is your cluster. Okay, so meaning that for each of the cluster that you have, each cluster you have, you will find the compactness of your cluster that you have. So if you have three clusters, each cluster, you need to find the compactness by finding the differences between the center and also all the points that you have. Okay, so how do we illustrate this one? For instance, we have this. We have three clusters here. Okay. Next, we need to find one. If we want to find the compactness, first we need to determine what is the center, the average log. So center K1 is 2.5, 2.55, 1.55, and 3. So we get that one by taking the average of this number, right? Similar to the rest. So this is our center. Okay. Okay, now we will apply for each of the cluster that we have, we will find the compactness. So for instance, like this, we have the center here. So the formula that we use is this one, sum of square error. Sum of square error means you find the differences and then you take the square and then you add up the value. So contohnya macam ni, the center is 2.5. Okay, so you need to find the differences here, which is 0.5. Take the square. And 4 minus this, you get 1.5. take the square. And you repeat sampai habis, then you get 2.75. So this is only the distance between the center to the first element in your cluster. So you repeat again the distance between your center to document 2. So you take the difference of this and so on, so you get 2.75. And the total is 5.5. So this is only the sum of square error for this cluster only. So you need to repeat for cluster number 2 and cluster number 3. Okay. So once you get all this, okay, this is the cluster number 1 is 5.5, cluster number 2 is 52.5, and then cluster number 3 56.68. So based on this, so you're looking at this, we are looking into summation of all the value that we have. So this is K1, K2, and K3. So this is the quantification of compactness of this, the result of this cluster. So what we can infer here, the smaller is the value, the more compact is your cluster, right? So if you want to compare, the one that has lower value will be much better cluster because more compact. Okay. Okay. So yang tadi itu choosing initial centroid will also affect the performance lah. Okay. But they will ask you how many times I should go. 10 times, 20 times. So what is the probability of you getting the right center? Okay, so they say, okay, if I compute the probability for me to get the right center, I will have this 0.00036 probability that I will get the right center. So they say, okay, sometimes it is good not to worry about this as long as you run this more than 5 times or 10 times. So do not run your clustering only one time. They said life is short, why need to worry about this? Okay, but just to inform you that you need to run few times to get. Of course, with the super computing power, you can do all this optimization. So that one is another area in which you can do investigation, the number of combination of center for your data. Okay, so this is just to illustrate you. Sometimes we get good result, sometimes we will not get them. So for instance, this one we should have 10 cluster, right? So based on the iteration, all the centroid go to the right place. From this, okay, so we have 2 here, and then 1 here. This one is bad example. So for this one, you will get this one is overlapping. Not overlapping, they have 2 centroid in one area. So that means they are split into 2. Okay. So just to give you the idea that sometimes we get good, sometimes we are not getting good cluster. Okay, so they say it's good to have multiple run, or you can use the hierarchical, because hierarchical, you just cut across to find the cluster and they have their own centroid. Okay, so limitation of k-means, Um, you will have problem when you have different size, density, and non-globular shape. Non-globular shape means they are not in the round shape. So for instance, like this, they have different sizes, right? But when you do the clustering, you will get this. Because they cannot see. You can see ada tiga cluster, but the algorithm cannot see. Okay? Or you have different density, you will have problem like this. Or non-globular shape. Huh? So what is the solution? Because the algorithm cannot see like us. So the best way is because your aim is to have a very compact cluster and they are far separated, right? So the only way we go for that is that we will have smaller cluster. So for this one, dari tiga, we form into multiple cluster. So we can maintain the compactness of your cluster. Or for this one, this is for the different density, and this is for the non-globular. Okay, boleh. Okay, so we take a break dulu. Macam tebu sudah kepala. 5 minutes.